Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help explain how to find asymptotes, both vertical and horizontal, and we'll go through another example or two of using them to graph. So we're going to take a look at quite a few of these functions here. Let's take a look at this one right here. So, all right, vertical asymptotes happen where the function goes undefined through a division by zero here. So as I take a look at this right here, if 2x, oops, get my pen on here. If 2x plus 2, or 2 plus 2x here, were equal to 0, we'd have a vertical asymptote. We'd have a division by 0 on the bottom. So x equals minus 1 is a vertical asymptote for this function. Right. Horizontal asymptotes happen when x gets really large. So this function, for large values of x, the top is approximately minus 7x, and the bottom is approximately 2x, and these divide out, so the function is approximately minus 7 halves, or minus 3.5. And y equals minus 7 halves is therefore a horizontal asymptote for this function. Let's take a look at this one here. So this one will have a vertical asymptote at x equals minus 1, because that will give us a division by 0. And hopefully I said that right, vertical asymptote at x equals minus 1. And for the horizontal asymptote, when x gets really large, 2 over a very large number is very, very small. So y equals 0 is the horizontal asymptote for this function. All right, let's take a look at this one. So, okay, vertical asymptotes. So if I take a look at x squared plus 1 equals 0, if you try to solve that, you get x squared equals minus 1. And this does not have a real solution to it. It's got what's called a complex solution or an imaginary solution, but it does not have a real solution. So this division by 0 is not a problem. So this does not have a vertical asymptote. Now, to find the horizontal asymptote, we'll just say this, that for large values of x, this function is approximately 4x squared up top and just x squared in the bottom, because x squared plus 1 for large values of x is approximately x squared. I don't know why that went away. But so you'll notice these divide out, and this function is basically equal to 4. So y equals 4 is our horizontal asymptote. Take a look at this one. So this one, that bottom factors here, so this is going to equal, this is x minus 3, and you notice this bottom is equal to x minus 3 times x plus 3. So here's an example. You'll notice that x equals 3 gives us a division by 0. So 3 is not allowed in this function. It's not part of the domain. However, you'll also notice that these cancel. So this is equal to 1 over x plus 3. Because these cancel, the value 3, even though it's not allowed, does not give us a vertical asymptote, because this function is effectively 1 over x plus 3. So the only vertical asymptote here is at x equals minus 3. Horizontal asymptote we get by noticing that the bottom is a higher power than the top. So as x gets large, the bottom is going to get bigger faster than the top. This function is going to go to 0. So the horizontal asymptote, y equals 0. All right, let's take a look at this one. And we may want to factor that one as well. This factors into x minus 1 times x plus 1 up top. That's the difference of two squares. And x minus 3 times x plus 2, I believe, in the bottom. I'll just double check that. Minus 3, 6. Yep, that looks good. All right, so here, nothing cancels. So a value of 3 will give us a division by 0, and so will a value of negative 2. So this thing is going to have vertical asymptotes at x equals 3 and at x equals minus 2. All right, to find the horizontal asymptotes. For large values of x, this function is approximately equal to just x squared up top and x squared in the bottom. Because for large values of x squared is a lot bigger than both x and 6. And this is equal to 1. So this will have a horizontal asymptote at y equals 1. All right, right, so that's how you find horizontal asymptotes. I think I'll move into more examples of using them to sketch graphs. So, all right, we're going to take a look at this function, y equals 2x minus 1 over x minus 2. All right, now, you'll notice that x equals 2 here is going to give us a division by 0. So this is going to have a vertical asymptote at x equals 2. I'm going to go ahead and just put this on our graph here. I think what I'll do here is just put a dashed line here. I think in my previous videos I color-coded it, but we'll just do this. All right, so what this means is this function, as it approaches this asymptote, it's going to do something like this, straight up or possibly straight down. We'll investigate that here in a minute. Okay, horizontal asymptotes. For large values of x, this function is approximately 2x up top and x in the bottom. Because for large values of x, 2x is way large compared to the minus 1. We can just lop that off. The same thing with the 2 in the bottom. These cancel. So we end up with 2. Right, so y equals 2 is a horizontal asymptote. Let's go ahead and put that in there. So we got x equals 2 and y equals 2 for this guy. All right, usually what we do is we plot a point or two. A really easy one to get. Let's see, how about x equals 0? You get minus 1 up top, minus 2 in the bottom, so you get 1/2. So this goes through the point 0, 1/2. That's about maybe here. Right. Let's run 1 through this function. So 2 minus 1 is what, 1 over minus 1. Let me just double check that. I'm putting 1 up top. Yeah, if you put 1 in for x, you get 1 up top, minus 1 in the bottom, so that goes to -1. So 1 minus 1. And pretty much certainly, oops, don't know why that did that, but all right, we sketch it. It's got to approach the asymptote here. And what you can do here is, in the interest of this video, I'm going to move on, but what you can do is kind of investigate what happens when x gets close to 2. So you might put in like 1.9, and I'm certain you're going to get some large negative number out of that. And if you put 1.99 in, you're going to get a very large negative number. Now, if we kind of investigate what happens to the left here, what should happen, I'm pretty sure that as we move to the left, this should approach 2. Let's try 1, 2, 3, 4. Let's try 5 out of this and see what we get. So if we put 5 into this function, 10, we're going to have 9 up top over 3. Let me just take another look at that again, putting 5 up top. 10, 9 up top over 3. Oh, whoops, I'm sorry. This was not matching what I was expecting to happen. That's because I was thinking minus 5 is the value. I want to look at what's happening over here. My apologies for that. So if we put minus 5 up top, let's see, we're going to have minus 10 and minus 1. We'll have minus 11 in the top of that. And we'll have minus 7 in the bottom. And decimal wise, what does that work out to? 11/7. And so that's 1.57 or so. So 1, 2, 3, 4, 5, 1.57 is about here. All right, and that's enough to sketch it. You try something like -20, you will no doubt get something very, very close to 2. All right, now we'll take a look at what's happening over here. 1, 2, let's try 3. And let's see, up top, we're going to have 6 minus 1 is 5. The bottom will have 1. So 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. And that's pretty well, I think, enough to probably sketch this. No doubt it's approaching the asymptote in this direction. So we come down here, it's got to approach the asymptote in this direction. All right, and there's our graph. There's a sketch of that. 1 or 2 more points would have made this a little more accurate, but this is just meant to be a rough sketch. We'll just call that good enough. So, in fact, I think what I'll do here is just stop this video right here. It's getting to be 10 minutes here, and I'm going to leave the next problem here as an exercise to the reader. I will make some comments on it, though. This will have vertical asymptotes at plus or minus 2 because of the bottom. And for large values of x, the top is approximately 2x, 2x squared. The bottom is approximately x squared. So y equals 2 is a horizontal asymptote. So this thing's got two vertical asymptotes, one at plus 2 and one at minus 2, and a horizontal asymptote at y equals 2. Then what you're going to want to do is build yourself a table. X, Y, start plotting some points, and that should be enough to get that graph sketched. So hopefully you'll have no trouble doing that. Have a great day.